The Avalanche Subnets and Elastic Blockchain Networks whitepaper expands on Avalanche's key innovation: independent, customizable blockchains called subnets. These subnets allow developers, institutions, and communities to build networks that fit their needs while staying connected to the Avalanche ecosystem. By separating consensus, execution, and validation, Avalanche introduces a structure that is modular, scalable, and adaptable across industries. In most blockchains, every validator must process every transaction. This ensures consistency but limits throughput and increases cost. Avalanche removes that bottleneck. It allows multiple blockchains to run in parallel, each validated by its own group of validators. These groups, known as subnets, define their own membership, fees, and governance. This horizontal scaling lets the network grow by adding subnets instead of overloading one global chain. A subnet is a dynamic set of validators that achieve consensus on the state of one or more blockchains. Validators can belong to several subnets, and subnets may be public or private. This flexibility allows both open systems and regulated environments to operate within the same framework. A financial institution could launch a permissioned subnet with compliance rules, while a DeFi app could deploy a fully open one. Each subnet runs Avalanche consensus, allowing hundreds of networks to operate simultaneously. Because the protocol is lightweight and parallelized, subnets scale naturally. Adding more networks increases total capacity without central coordination. They can also evolve independently, adjusting parameters or splitting when demand rises. This creates a living, self-adjusting ecosystem that grows with participation. Elasticity refers to a subnet's ability to adapt to changing conditions. Unlike traditional blockchains, subnets can modify configuration and resource allocation as they evolve. When activity increases, validators can be added. When priorities shift, settings can change without disrupting other networks. This adaptability ensures stable performance across a wide range of workloads. Economic incentives drive the system. Validators must stake AVAX on the primary network to secure the ecosystem. Within subnets, creators can define custom tokenomics, how fees are collected, distributed, or burned. This freedom allows each subnet to align its economy with its purpose, whether for trading, gaming, NFTs, or enterprise applications. Subnets can also use custom virtual machines. Developers can choose the Ethereum virtual machine for compatibility or design entirely new ones for specialized tasks. This modularity encourages experimentation without altering Avalanche's core protocol. Communication between subnets is handled through Avalanche Warp Messaging, or AWM. This native feature lets subnets exchange verified messages and assets securely without external bridges. It turns Avalanche into a true network of networks, where blockchains remain autonomous but interconnected under a shared security layer. Governance is equally flexible. Each subnet can implement on-chain voting, committee-based decisions, or automated logic. Founders set the rules for upgrades, validator membership, and fees. Meanwhile, the Avalanche primary network remains the foundation of trust, enforcing the universal standards of staking and security. This structure balances autonomy with unity, keeping the ecosystem decentralized yet coordinated. Subnets help solve the blockchain trilemma of scalability, security, and decentralization. Instead of one global network handling everything, Avalanche enables many specialized chains to coexist under one infrastructure. Each subnet is optimized for its purpose but still benefits from Avalanche's speed and consensus guarantees. Use cases span multiple sectors. Game studios can create subnets for fast in-game transactions. Enterprises can run private networks for compliance and data integrity. Governments can issue digital currencies or public registries. Every subnet becomes a self-contained environment tailored to its function, while still interoperable with others. Elastic networks also strengthen resilience. If one subnet becomes congested or fails, the rest of the ecosystem remains unaffected. Networks can scale by adding validators or by branching into smaller subnets. This modular design isolates problems and maintains performance even under stress. Ultimately, the Avalanche Subnets and Elastic Blockchain Networks whitepaper outlines a vision where blockchain infrastructure behaves like cloud computing, scalable, adaptive, and interconnected. Each subnet is a programmable space that can evolve, specialize, and collaborate with others. Instead of competing for limited block space, developers can create purpose-built environments that remain part of a unified ecosystem. Avalanche shows that decentralization can be flexible. Through subnets and elastic networks, it delivers a model of blockchain architecture that scales indefinitely without sacrificing speed or security. For more insights on Avalanche, subnets, and